Ever wondered about the current state of automotive brake rotors and how they've evolved over time? The automotive brake rotor, a critical component in the braking system of a vehicle, is the unsung hero of our safety on the road. It's a component that's constantly innovating, evolving, and adapting to the needs of modern vehicles. In the current state of affairs, automotive brake rotors are designed to prioritize safety and performance. The rotor's primary job is to absorb and dissipate the heat generated from the friction between the brake pads and the rotor itself. This process is crucial in slowing down or stopping the vehicle. However, it's not as simple as it sounds. The brake rotors face a constant challenge of dealing with high levels of heat. If not managed correctly, this heat can lead to brake fade, a condition that reduces the efficiency of your brakes and can potentially lead to accidents. Moreover, the wear and tear of these components pose another significant challenge. Over time, the intense friction and heat can lead to the warping of the rotor, which can cause vibrations and a less responsive brake pedal. Even though modern brake rotors are designed to be robust and durable, these challenges necessitate continuous innovation in this field. Engineers and scientists around the globe are constantly striving to develop more efficient, heat-resistant materials and designs. This ongoing research aims to enhance the longevity of these essential components and ensure your safety on the road. In the face of these challenges, it's clear that the evolution of brake rotors is a testament to human ingenuity and the relentless pursuit of safety and performance. Now that we've grasped the present scenario, let's take a trip back in time to understand the journey of brake rotor invention. Imagine a world without brake rotors. Sounds chaotic, right? Thankfully, someone invented them. Let's take a journey back in time to the early 20th century when cars were becoming more commonplace. But there was a problem. Stopping these fast-moving machines was a significant challenge. Enter the brake rotor, a remarkable invention that revolutionized vehicle safety. The invention of the brake rotor is attributed to Frederick William Lanchester, an English polymath and engineer. In the early 1900s, he observed the need for a more effective braking mechanism as cars became faster and more powerful. His solution? The brake rotor. Unlike drum brakes, which were commonly used at the time, Lanchester's brake rotors provided better heat dissipation, leading to more efficient and reliable braking. Let's visualize a spinning disc gripped by brake pads on either side. This is the basic premise of a brake rotor. When the brake pedal is pressed, hydraulic pressure forces the brake pads against the rotor, creating friction which slows down and eventually stops the vehicle. This simple yet ingenious design was a game changer. It made vehicles safer and paved the way for the evolution of modern braking systems. It's hard to overstate how important this was. No longer would drivers have to rely on inconsistent and unpredictable drum brakes. Now they had a reliable way to stop their vehicles thanks to the brake rotor. Over the years, the brake rotor has undergone numerous enhancements. Engineers have experimented with different materials to improve heat resistance and durability. They've also tweaked the design, adding vents and slots to further improve heat dissipation and reduce brake fade. But it's not just about the rotors themselves. The development of brake pads, calipers, and hydraulic systems have all played a crucial role in improving the effectiveness and reliability of brake rotors. From their inception, brake rotors have come a long way thanks to continuous improvements and advancements. And, as we'll see in the next scene, even NASA has had a hand in pushing the boundaries of brake rotor technology. Did you know that NASA, the space agency, has played a significant role in advancing brake rotor technology? Yes, it's true. The same organization that takes us to the stars has also been instrumental in keeping our cars safely on the ground. How, you ask? Well, let's delve into the fascinating story of NASA's involvement in brake rotor innovation. In the mid-90s, NASA embarked on a project aimed at improving brake rotor technology. This initiative was driven by a need for better, safer, and more reliable braking systems for their spacecraft and rovers. As it turns out, the challenges faced in space travel have a surprising amount of overlap with those encountered in the automotive world. NASA's team of engineers and scientists began to experiment with new materials and designs, aiming to create a brake rotor that could withstand extreme temperatures and conditions. They turned to the world of ceramics, specifically a type known as silicon carbide. This material is incredibly tough, resistant to wear, and, crucially, can withstand high temperatures without losing its shape or strength. Through rigorous testing and refinement, NASA was able to develop a new type of brake rotor that was lighter, stronger, and more heat-resistant than traditional metal rotors. This was a game-changer, not just for space exploration, but for the automotive industry as well. NASA's breakthroughs didn't stop at the laboratory door. Recognizing the potential of this innovation, they made their research available to the public. Automotive manufacturers around the world seized upon this new technology, incorporating it into their own designs and giving us the high-performance brake rotors we know today. So the next time you're driving and you feel that smooth, reliable braking power, remember to thank NASA, not just for the stars in the sky, but for the safer roads beneath our wheels. NASA's research and development have indeed given the world a break, or should we say, a better break. With NASA's contribution, the future of brake rotors looks promising, but what exactly can we expect? As we venture forward, it's exciting to imagine the possibilities of what the future might hold for brake rotor technology. The advancements we're likely to witness will not only be influenced by the ongoing research and development efforts of organizations like NASA, but also by the demands of a rapidly evolving automotive industry. One of the key areas of focus in the future of brake rotors will be material development. While cast iron has been the go-to material for rotors for many years, we're already seeing a shift towards more durable and efficient materials. Composites, for example, are being explored for their incredible strength-to-weight ratio, not to mention their resistance to heat and wear. Could we see a future where carbon fiber or even graphene-based rotors become the norm? It's certainly a possibility worth considering. The design of brake rotors is another area ripe for innovation. Engineers are constantly striving to optimize rotor design for better heat dissipation, improved performance, and reduced weight. The diamond cut patterns we see on some high-end sports cars today might just be the tip of the iceberg. With the help of advanced computational simulations and 3D printing technology, we could see the emergence of intricate rotor designs that were previously unimaginable. And let's not forget the potential impacts of electric and autonomous vehicles on brake rotor development. As regenerative braking becomes more commonplace, the demand for traditional brake rotors might decrease, but that doesn't mean they'll become obsolete. Quite the contrary. It could lead to the creation of hybrid systems that blend the best of both worlds, offering enhanced braking performance and efficiency. While we can't predict the future with certainty, one thing is clear: the journey of brake rotor innovation is far from over. So, buckle up and get ready for a fascinating ride as we watch this space for the next big leap in brake rotor technology. So, what have we learned today about brake rotors and their fascinating journey? Well, for starters, we've uncovered that despite the ubiquitous nature of automotive brake rotors, their design and function are far from simple. These integral components of our vehicles have a rich history and a complex operational mechanism that are central to our safety on the roads. We've journeyed back in time to the invention of the brake rotor, understanding the initial challenges faced by engineers in creating a device that could halt a moving vehicle with minimal friction and maximum efficiency. It's a story of trial, error, persistence, and ultimately innovation. Then, we turned our gaze skyward to the National Aeronautics and Space Administration. Who would have thought that NASA, an organization known for exploring the cosmos, would play such a pivotal role in advancing terrestrial automotive technology? Yet they have, by applying their knowledge of managing extreme temperatures and forces in space to the improvement of brake rotor technology. NASA's involvement has brought about a new era of brake rotor design, leading to increased safety and efficiency in our vehicles. Looking forward, we envisage the future of brake rotors. With the advent of new materials, technologies, and design concepts, the brake rotor is set to undergo further evolution. The possibilities are endless, from rotors that regenerate energy while braking to those that adapt their functionality according to driving conditions. In summary, The journey of the brake rotor is a testament to human ingenuity and the relentless pursuit of improvement. It's a story of how a simple yet crucial component of our vehicles has evolved over time, influenced by unexpected sources, and is continually being redefined for the future. Next time you hit the brakes, remember the fascinating journey of innovation and improvement that has brought us to this point.